Hey everyone, my name is Micah Hausler. You are at KUB315 securing Kubernetes workloads in Amazon EKS. I'm a principal software engineer at AWS. I work on Kubernetes security. I contribute to upstream Kubernetes. I'm on the Kubernetes security committee. So we take in security reports and evaluate them and then issue fixes to Kubernetes.
And I'm John. I'm a product manager with Amazon EKS team. I'm very excited to be here, and thank you all for taking the time to join us today.
Am I on? Sure.
Okay.
Great.
So for today's session, we thought we'll take a different approach. We are going to look at how you can secure your workloads running in Amazon EKS from a few different layers. So first, we'll take a look at the big picture. We look at the controls that are available to you at a cluster level. So we look at how you can secure access into the cluster. We look at how you can assign permissions to applications running in the cluster so it can access AWS resources outside. So things like S3 buckets, DynamoDB, how you can securely set that up. And finally, in the first section, we look at how you can use the various AWS services in the security space and how those integrate with Amazon EKS. And then we'll dive a little bit deeper. We'll go into the infrastructure layer. So by infrastructure here, I'm referring to the EC2 instances, the worker nodes that you run in the cluster. And we'll also look at some of the networking, VPC, and what are the controls and mechanisms available for you to secure the infrastructure layer. And then finally, we'll jump into the application layer. We'll talk about the best practices, some of the controls to secure your images and pods that make up your application. So one thing I want to call out is that in today's session, our focus is really on EKS and AWS controls and capabilities that are available to you. But at the end of the session, we'll share a resource, namely the EKS Best Practices Guide that talks about the Kubernetes capabilities and tools that are available so that you get the full picture in terms of how you can secure your cluster. So with that, let's get started. So over the last few years, we have seen a massive uptick in adoption of Kubernetes. As per the 2023 Cloud Native Computing Foundation's annual survey, 84% of the respondents are using Kubernetes either in production or evaluating it. And this is something we are seeing at Amazon EKS. Every year, we have customers running tens of millions of clusters, and this number keeps growing. And when we launched EKS over 6 years ago, it was really in response to customer feedback that managing Kubernetes at scale is hard. Customers were spending a lot of time monitoring, scaling, managing the Kubernetes control plane, and they wanted a native way to integrate with the various AWS services. And since then, EKS has emerged as the most trusted way for you to run Kubernetes in AWS. Now, we removed the undifferentiated heavy lifting of not just managing the Kubernetes control plane, but various other aspects of the cluster. For AWS and EKS, security is the highest priority. When we, as always, operating securely in the cloud is a shared responsibility. AWS takes responsibility for the security of the cloud, and you as a customer takes responsibility for security in the cloud. So here you can see at the bottom 3 layers are all managed by AWS and EKS. So things like the Kubernetes clusters control plane, the infrastructure it runs on, the regions, the local zones, some of the foundational services the control plane leverages, like the compute, storage, networking, and the actual Kubernetes bits, like the API server that runs in the control plane, the etcd database. All that is our responsibility. We patch, we scale, we manage, we make sure it's available and resilient. And the layers above it are really the EC2 instances and the worker nodes that run in your VPC. Things like whether the operating system that runs on the EC2, whether it's patched, whether it's monitored, whether you are looking at the health of it. Some of the cluster capabilities like auto scaling, and even the Kubernetes pieces, the binaries that run on the worker node, like the kubelet or the container runtime, all that is your responsibility. But AWS and EKS offers you various tools, like there are multiple capabilities like security groups on pods, subnets, private endpoint access, EKS add-ons, EKS optimized armies, all of which will make it easy for you to secure your data plane, your VPC, and the things that run there. But at the end of the day, it's still your responsibility. Now that we have covered some of the basics, let's jump into the first layer. So first we look at, like I said, the cluster level controls. When we launched EKS, we wanted to offer a Kubernetes native way for authenticating into the cluster. So what we did is we have this config map called AWS auth, where you can define the mapping of IAM principles to Kubernetes permissions. Now, this approach had some trade-offs. On one hand, it was good because you can use IAM. You don't need to maintain a separate identity provider. You get all the benefits of IAM, like multi-factor authentication, the auditing with CloudTrail logs, and so on. But on the other hand, now you had to deal with different set of APIs to create an EKS cluster with all the permissions. For example, you would use EKS APIs to create the cluster, and then you have to move to Kubernetes APIs to provision the mapping and set up the config map. This meant that automating or using infrastructure as code tools to bootstrap a cluster with the required permissions is hard. Another challenge with the config map experience was it was a little bit brittle. Like if you make a typo in the config map or you don't follow the exact format, you could accidentally lock your users out. And there were behaviors like when you create the IAM identity that is used to create the EKS cluster, automatically gets super user access. Now, this was something which was behavior which many customers didn't like. So to address these, soon after reInvent last year, so Mike and I were on stage last year, we talked about it as something that's coming out. It came out as a feature soon after reInvent called Cluster Access Management. What Cluster Access Management does is that it kind of unifies the APIs. So no longer you're switching between EKS and Kubernetes APIs. Instead, you can just use EKS APIs to create the cluster, set up the permissions, you have cluster ready to go. And it simplified the configuration, so users and other AWS services that needed access to the EKS, the whole setup was much more simpler now. And finally, it gave you granular control. So if you remember the scenario I mentioned before, now with Cluster Access Management, you are able to revoke the permissions granted automatically to the IAM principle that creates a cluster. There is a link to the blog at the bottom. If you are interested in learning more about it, please take a look. We strongly encourage you to take a look at Cluster Access Management. For EKS, that is the future. That is where we are heading. All the new features, all the capabilities will be built on Cluster Access Management. And if you have an existing cluster that's using the older AWS auth config map, we strongly encourage you to move. There is a simple, easy way to migrate from from config map to Cluster Access Management. Let's look at the actual flow behind the scenes. So first, you would be integrating with or interfacing with IAM to create the IAM principle, whether it's a role or user. And then you would be interfacing with the new APIs that were introduced as part of the feature. The same functionality is also available on the console. So you can either use EKS console or you can use the APIs. And then you would be creating two main entities. First one is access entry. So access entry would associate with the IAM identity you created in the previous step. And then you create an access policy and use access policy to specify the permissions that the access entry has. So once the first two steps are done, you have pretty much set up the feature, the Cluster Access Management feature. And then let's say you have a user who's trying to access the API server. What happens is implicitly AWS STS is called either by IAM Authenticator or the CLI get token operation. And when the request lands in the control plane on the API server, we have a webhook which intercepts the request, looks at the STS token, tries to find the user identity associated with the token. And then if it does a matching with the access entry, if that succeeds, authentication is complete. The next is authorization. For authorization, there is a series of authorizers that we look at. And then if the user identity maps with the access entry and access policy, the authorization is also allowed, and then the request can flow in. Cluster Access Management is available both through APIs and console, so you have the flexibility there. All right, so the first part I talked about is how can you set up access into the cluster. Now we'll move on to, you have an application running in the cluster. Most likely you might need to access an AWS resource. And you could have a Kubernetes application that needs to access S3 bucket. It could be DynamoDB table. It could be any AWS resource. How do you make sure you assign the right permissions to the application? So one option we had previously, and it's still available, is called IAM roles for service account. In short, it's called IRSA. So we launched IRSA in 2019. IRSA enabled you to grant granular AWS permissions to pods. So you could have multiple pods belonging to multiple applications, all running on the same EC2 instance, but have effectively different set of permissions. Now this was launched in 2019, like I said, and our goal was to make sure IRSA works across the different Kubernetes deployment models we support in AWS. So we wanted IRSA to work with EKS managed service in the cloud, EKS anywhere, self-managed Kubernetes clusters on EC2 instance, Red Hat OpenShift service for AWS, ROSA in short. So we built IRSA by not taking a direct dependency on any of the EKS APIs. We leveraged some of the foundational services like IAM, but that had some trade-offs. One was, now that we are depending on IAM for IRSA, you had to create an IAM or OIDC provider. Now this was a privileged operation. We heard from some customers, especially customers in regulated industries, that the cluster administrator doesn't have IAM permissions. So now it means that the cluster administrator has to reach out to IAM administrator. There's a lot of back and forth to set up IRSA, which was not very user friendly. The other one was the scoping. So when you use a role or when you create a role for use in IRSA, you typically have to bound that role or specify what are the clusters that can assume this role. Now it means that if you want to use a role in a new cluster later on, you have to go back to IAM role, keep updating the trust policy, or if you want to revoke a role from a cluster, you have to go back to the roles trust policy and keep playing with it. And finally, there were some limitations in terms of how many clusters can a role be used with. And to address these, at reInvent last year, we launched the feature called Pod Identity. So Pod Identity simplifies trust. Pod Identity enables you to create a role that can be assumed by EKS service as a whole. So previously, when you create a role, you specify the clusters that it could assume. And now with Pod Identity, you can just specify that AWS service can assume it. So it doesn't matter which cluster you're using, but you also have the ability. If you want to lock it down to a few clusters, you have that ability as well. It offers new capabilities like attribute-based access control by supporting IAM role session tags. So it enables reuse of policies and roles across clusters. And finally, you're able to now create clusters with all the required permissions in one go. And there is a link to a blog at the bottom if you are interested in learning more about Pod Identity. So one thing I want to emphasize is that, like I said, cluster access management is the future. For the previous talk, the first part of this talk, I said AWS auth config map is the older way. But here, IRSA is not the older way. We'll support both. We have no plans to deprecate IRSA. IRSA would continue to exist along with Pod Identity. Pod Identity is purpose-built for EKS managed service in the cloud. It doesn't work with EKS anywhere or self-managed Kubernetes clusters on EC2. So it's all about giving you more options. Depending on your use case and needs, you can pick the solution that best fits your needs. All right, let's look at the flow. For Pod Identity, a prerequisite is that you need to run a Pod Identity agent as a daemon. So it needs to be running on all worker nodes. So here, let's take a very simple scenario. Let's say you want to deploy an application to your cluster that needs to access an S3 bucket. It could be any AWS resource. I'm just using S3 as a simple example here. The first thing is you would be interfacing with or using IAM to create an IAM role. An IAM role has two parts, a permission policy and a trust policy. A permission policy is where you're specifying this can access S3. So in our case, we want the application to be able to access S3. The permission policy would have the permissions for it to access S3. And then you have the trust policy. This is where Pod Identity is different from IRSA. The trust policy for Pod Identity specifies that this role can be assumed by EKS as a service. So we have a new service principle we introduced, and that's a one-time step. It doesn't matter whether this role is used on cluster A or B or C in the future, it will just work. And it's a one-time step you have to do. And after that, what you do is you use the Pod Identity APIs. Again, you can use the console if you want. But there is an operation called create Pod Identity association, which is how you map the IAM role that you previously created with the service account. So one good thing here is that service account, the Kubernetes service account, need not exist at that point in time. It can be something you create in the future. The good thing about that is if you are a cluster administrator, you want to set up the cluster with all the permissions. So when the app dev teams comes in later, that cluster is ready to go for them. You can pre-create the Pod Identity association with all the mappings ahead of time. Now, these are the two things you do to set up Pod Identity the feature. And then let's say later on your app dev team is deploying their application, a pod is spun up. When we detect that this pod has a service account associated with it, which was previously mapped through the pod identity association, we have a webhook that intercepts the request and will mutate the pod spec. And we'll add a couple of environment variables, well-known environment variables to the pod spec. So when AWS SDK comes up, it knows these environment variables. It would mount these, it would fetch the service account token that's mounted to the pod. It will make a call to the pod identity agent, pass the token, the service account token, and then the pod identity agent would then call assume role for pod identity, which is a new API we introduced as part of the pod identity API. And this API would then validate the service account token that was passed. If it is validated, it returns a temporary AWS credential, which is then injected into the pod. And then the application can use that AWS credential to access S3. All right, so what's new in pod identity since the launch at re:Invent last year? Pod identity is now available in all commercial AWS regions and China, as well as the US GovCloud regions. We open sourced the agent itself. So when we launched it, it was only available as an EKS add-on. We got feedback from customers that they want to deploy it as a Helm chart or want to bake it into their own army and create a custom army. So the agent is now open sourced. And the last one is we introduced support for pod identity in EKS add-ons. So add-ons are operational software that you can run in the cluster. And these software usually needs permissions, AWS permissions, to access AWS resources. Previously, the only way you could set that up was through IRSA, but now pod identity is also available, which greatly simplifies the add-on setup experience. All right, so now let's move on to some of the controls that are available for you to identify and alert on issues. The first thing is looking at the access, the requests that are coming into the API server itself. So when you create an EKS cluster, you get a cluster endpoint, which is basically the API server that's running in the control plane. All the requests coming into the API server are logged in the control plane audit log, and they are made available in CloudWatch. This is an opt-in or something you have to enable. But once you enable control plane logging, the logs will automatically flow to CloudWatch. Now, it being in CloudWatch means that you can use things like CloudWatch log insights to further analyze it. At the end of the presentation, we'll share the security best practices. Within that, there is a section called detective controls. And there are some pre-built CloudWatch log insights query we have found to be useful. So that is something you want to probably take a look at after the presentation. The other benefit of it being in CloudWatch is that you can set up alarms. So if you want to detect an increase in 403 forbidden or unauthorized access, you are now able to kind of alert yourself to those situations. All right, so next one is, so previously we looking at the requests that are coming into the API server endpoint of the cluster. This is about looking at the requests that are coming into the EKS API. So here EKS API is the EKS service APIs that you use to create cluster, delete cluster, update cluster, all of those EKS APIs, not Kubernetes APIs. All of those are logged in CloudTrail, and along with CloudTrail logs and CloudTrail insights, you are able to analyze them. And finally, we have Amazon Detective. So all VPC flow logs, if you want to analyze or visualize them, you can use Amazon Detective, which is integrated with EKS. Next is encryption. So with some of the native AWS storage options like EBS, EFS, FSX for Lustre is supported in EKS. You can encrypt at rest with either AWS managed keys, or you can bring your own keys. Along with that, some of the secret sensitive information that's stored in the Kubernetes cluster is typically stored in the Kubernetes secrets object. EKS gives you the ability to encrypt the secrets object either with the key that is the AWS key management service offers, or you can bring your own key to KMS and then use that to encrypt it. And with the keys being in KMS, you get the ability, you get the benefit of automatic rotation offered by KMS. So what are some of the other cluster scoped controls that are available to you? The first one is the Kubernetes cluster endpoint. So here, when I say Kubernetes cluster endpoint, I'm referring to the API server endpoint that's available in every cluster. By default, it's in a public mode, meaning that any traffic originating from your VPC, if it has to reach out to the API server, let's say your worker nodes need to reach out to the API server, the traffic leaves the VPC, it remains in Amazon network, and then comes back to the API server. But if you, let's say, you want to make it completely private so the traffic always remains in VPC, you have the option to configure the endpoint to be in a private mode. The next one is the other API, which is the EKS APIs. So today, again, if you have a need where any traffic originating from your VPC should hit the EKS APIs through a private endpoint or in a private manner, there is AWS Private Link. That this feature I think we launched a year or so ago. So you can leverage AWS Private Link with EKS service to kind of get that private connectivity. The next one is use manage components whenever you can. So EKS add-ons, EKS optimize Amazon machine images or armies. These are something we take responsibility for. We always are looking for issues. If there are vulnerabilities, it is on us to go patch it and make a new version available. And then there are APIs that you can leverage to apply those to your cluster. So when possible, you leverage managed components. And the last one here is using Security Hub for scanning your cluster. Security Hubs has, I think, around 8 predefined checks to look at the security state of your cluster. So that is something you can also look to get an idea of how your cluster is from a security standpoint. All right, with that, let me invite Micah.
Thanks, George. So the next section is around infrastructure scope security controls. So as George talked about, we kind of are separating cluster from infrastructure. So by infrastructure, we really mean where does your containers run? And the first thing that we're really excited to talk about is EKS Auto Mode. This was just launched yesterday, so you're getting the fresh stuff. EKS Auto Mode is a new feature of EKS that helps you to automate your entire Kubernetes cluster infrastructure. So with Auto Mode, AWS takes responsibility for creating and deploying nodes. You only have to create your pods. What this really allows you to do is improve performance and optimize resources. Using Carpenter, which is an open source project that we created, we manage that completely for you, and we will create the nodes that are required for the pods you define. If you define a pod that requires X amount of memory, Y amount of CPU in a specific AWS zone, we'll create it there. Similarly, as you scale up, say, a Kubernetes deployment and add more replicas, we will create the best type of EC2 node for you. Similarly, we will also consolidate and find the best type of nodes for the workloads that you have running. This really simplifies the management of your cluster. You don't have to think about creating a node group, which zones do you want to create it in. You just have to use the Kubernetes API to create a configuration for EKS Auto Mode. And also this really reduces the operational overhead required. You don't have to think about updating the machine images that AWS is responsible for creating and making available to you. You just use the nodes. Nodes have a max lifetime of 21 days. So even if you have a workload that's running more than 21 days, that node will get recycled, and gracefully your application will get recreated onto another node. That's the latest Amazon machine image with the latest security patches, and so it's always up to date. This really helps you increase your own agility and accelerate your own innovation, because you're not having to spend time trying to keep all your nodes up to date. You really get to offload all of these operations to AWS. This also just really helps you improve the performance and availability of your application. As I said before, it's graceful restarts, graceful migration of nodes. So you don't have to think about what sort of scaling policies you have to apply to an auto-scaling group. This will do it for you. And finally, this really does help you optimize costs by automating the capacity planning and dynamic scaling. You don't have to go say, okay, what kind of node, what's the best type of node that I need for my workload? We'll determine that based on the requests in your Kubernetes pod. So this, as George shared earlier, we have a shared responsibility model. And with EKS Auto Mode, this changes a little bit. In the previous example, if you're using EKS managed node groups, there's more of the responsibility that's on you. In this model, all that's on you is really maintaining the security of your containers and your VPC infrastructure and any add-ons that you install on top. There's a number of add-ons that are automatically included with EKS Auto Mode. Things like the kubelet, the container networking interface, the KUB proxy, and some CSI drivers. Those are automatically maintained by us. But other add-ons, those are still on you, but there's just a whole lot less that you have to manage. Another aspect to talk about in terms of the cluster security is really about cluster network security. So you have applications running on containers and pods in your cluster, right? There's two main configurations that you have here. The first is to take advantage of Kubernetes networking policy. So this is part of Kubernetes as the interface, and then powered by the AWS VPC Container Network Interface, or CNI plugin. You can define rules in the Kubernetes API that say, I want to let pods in this network namespace talk to pods in this other network namespace. You get very granular control over pod labels, or even at the pod label level, and L7, so what host name or what TCP port. That is enforced on the host. So it's using eBPF in the EKS VPC CNI. If you're using a different CNI plugin that with a different enforcement layer, that might be using a different technology, but that's enforced on the host. The other method is with security groups. So these are the same security groups you know and love with EC2, but they can be applied to your Kubernetes pods. So each pod in Kubernetes that uses an elastic network interface, or an ENI, that gets attached to your EC2 instance. And EC2 security group per pod attaches a security group to that pod's network interface. So this lets you use an off-host mechanism that can't be modified on the host to control what network calls a pod can make. And included is a link where you can read more about that. As George mentioned, there's some detective controls that you can do with CloudTrail. Another form of detective controls, more around the infrastructure layer, are around GuardDuty. So GuardDuty has some really great integrations with Amazon EKS. The first integration that we built with GuardDuty was for audit log protection. So Kubernetes has an audit log. Kubernetes is an API server. It emits an audit log for every request that's made against it. This audit log includes things like, if you create a pod, it tells you the pod name, which user created the pod, other metadata about the pod. And all this goes to a central log. You can turn it on, send it to your account, but with GuardDuty, you can also have that log sent to GuardDuty for your cluster. GuardDuty has uses machine learning. It also uses quite a bit of rules that we've observed from known attack patterns. And we interface with the GuardDuty team a lot to say here's new things that are coming in Kubernetes. Here's new things we should look for either misconfiguration or attack patterns. And so GuardDuty will send you an alert if it detects either a misconfiguration. If you say you accidentally configure anonymous, so unauthenticated users to the Kubernetes API as admin. I've seen it before. It's awful. Don't do it. But if you did it, you would get an alert from GuardDuty saying, hey, this happened, you should go remediate this. And same for a bunch of other known attack patterns. So that's a really, really great protection mechanism. You can enable at your account level to say, I want this for all my clusters. Second is Amazon GuardDuty's detective controls is with runtime protection. So Amazon GuardDuty also has an agent-based mode where they will deploy through EKS add-ons an agent onto every host to look for known attack patterns, whether that's through file changes or other known heuristics on the node to look for malicious attack patterns that wouldn't show up in the Kubernetes audit log, but could be seen in, say, the Linux audit log. So that's another great control. Again, you can turn that on at the account level or at the AWS organizational level for your account to just make it enabled on all clusters. A few other infrastructure scope security controls that we just recommend for customers are to restrict and minimize access to your instances using AWS SSM. So if you're used to spinning up a VM, if you ever pointed and clicked through the AWS console, your first time you probably used SSH, right? Everyone's sort of familiar with SSH, generating SSH keys, configuring that on your instance, and then opening a port on your security group and getting an IP address and connecting to your host. That is, when you've done that, I would not be surprised, and you can be ashamed, it's okay, to have set the incoming security group rule to allow anywhere in the world, because I don't want to go look up my IP. What if I'm at home and my IP changes, or if I'm at an office and I have a floating IP, right? You might set it to the whole world. That's not great, but you might have done it, right? You don't want to do that in production. And so with AWS Systems Manager, you can turn off SSH and enable SSM to access your hosts. And the SSM agent connects back to the SSM service. And with SSM Session Manager, you can log into your instance through SSM without needing that open port. So it's a great security control that's not necessarily unique to EKS, but just a best practice that we really recommend, because it really can save you from having misconfigured an open port to the world. You just don't need to do that for something like SSH. There's all kinds of internet bots and everything scanning, the global IP space looking for what's listening on port 22, and you don't want to be hit there. Additionally, we recommend using a container optimized OS. So we have the Amazon EKS optimized AMIs. Those are using Amazon Linux. And then we also have BottleRocket, which is using the same kernel with Amazon Linux, but using a more hardened container-only, container-first OS. EKS Auto Mode actually uses BottleRocket under the hood. But BottleRocket is a much more locked down OS that doesn't have, it's not a general purpose OS, it doesn't have a package manager. So you can't keep packages up to date. You don't have to keep packages up to date. You create a new instance when you need a new package or to get a security patch. And then finally, we also recommend just verifying your configuration of your cluster using the CIS benchmark. We have an EKS specific CIS benchmark that lets you verify the configuration of your cluster, making sure you have things like if you don't want public access to your cluster turned on, you can have that turned off. Making sure that you have all the other APIs that we've talked about, like cluster access management, making sure that you're using no longer using config map mode. You can use the CIS benchmark with open source tools like KubeBench to validate your configuration here. And finally, the final section here is really to zoom in to the application scope security controls of your cluster. So as we mentioned, pod security is kind of one of those things that you need to pay attention to, right? So one of the best mechanisms for this is really using either in-tree Kubernetes pod security standards or some external pod security, so policy as code solution. There's open source solutions like Kyverno or Open Policy Agent Gatekeeper or others out there that help you enforce some of your security standards as code. Some of the best, just to hit some highlights here, there's a whole slew of them. Again, we'll have a link later to the EKS Security Best Practices Guide with these. But a few ones we just really want to call out because these are just so critical is limit the privilege containers. And I'm specifically using the word limit here because sometimes people think they should never have privilege containers. And if you're not familiar with privilege containers, if you ever run Docker and Docker command line, you have the -- privilege flag. When you run privilege, that gives a container access to all kinds of Linux devices and privilege escalations on the host so that it can do management of the host. Sometimes that's necessary. So when we say limit, we don't mean eliminate privilege containers. For example, the AWS VPC CNI needs to set up network namespaces so that pods can have their own network on a host. That needs to be privileged. There are things like the CSI, the Container Storage Interface agents for EBS or for EFS or several of the other Amazon integrations. Those might need to be privileged, and that's okay. But what we do encourage you to do is limit that. So if you have an application that's serving web traffic, it probably does not need to be privileged, so don't make that privileged. Similarly, if you have an application that's running on your cluster that is, again, take this web serving traffic example, that's never going to talk to the Kubernetes API, disable service account token mounts. By default, Kubernetes mounts a token into every pod so that it can talk to the API server and authenticate. Doesn't have any permissions by default, but it's there as an authentication mechanism. If you don't need it, turn it off, right? Similarly, restrict use of host path. It's just one of those things that if you don't need, turn it off. There's all kinds of CVEs in the past, whether that's in Containerd, in Kubernetes itself, or runc, the container runtime agent, that have centered around host mounts. So if you don't need them, turn them off. And then finally, just as you build your container images, when you define that, whether it's in your Docker file or however you're defining your container image, or actually not in your Docker file, but actually in your pod configuration, if your pod, say, again, we'll take the web traffic example. If the pod never has to write, or the application in your pod never has to write to the file system, consider switching that to a read-only file system in your container. That eliminates a whole slew of attack vectors that your application could potentially be vulnerable to, and you just don't even have to worry about. Another aspect that we like to think about is just image security. So your images that you're running are pulled from somewhere, probably Amazon ECR, maybe somewhere else. We highly, highly recommend scanning these for vulnerabilities regularly. So with Amazon ECR, you can use the native Amazon inspector integration and get scans of your image and reports if there are security vulnerabilities found in your application. Whether that's in the system packages or there's some support for language packages as well. Also, when you're using ECR, if you don't need ECR to be coming from outside of your VPC, you can use ECR with private link. You can lock down so that your image can only come over private link. That's a great control that we've seen customers use. And finally, similar to the read-only file system, this is more a thing that you have to configure in your container definition when you build it, but configure your image to use a non-root user. It's sort of a default. If you ever use a Docker file when you build, it just uses the root user. If you're listening, if you have a web container that's listening on whatever port it is, it doesn't necessarily need to be running as root. And so you can change that to a non-root user. That, again, just reduces the permissions that Linux process has when it runs in your cluster, so that it has much less likelihood of, if there is a security event, of having permissions to escalate and do things that you don't want it to do. The next part I want to talk about is something that we're pretty excited about. So this is pretty new. So Kubernetes has built-in authorization. If you've ever used Kubernetes, you've probably configured RBAC, or role-based access control. And you've probably written an RBAC policy to allow some pod to manage things in your cluster, or maybe a human to manage things in your cluster, right? If you've ever written an RBAC policy, quick show of hands, how many of you have ever written an RBAC policy? Okay, good. We got a lot of people here. Okay, so if you've ever written an RBAC policy, you've probably come into some of the limitations of this. It's worked great in Kubernetes for the last like 8 years or so, but the more and more that we've heard from customers, we're seeing some of the limitations of RBAC come into play. If you've ever written an RBAC policy, you know that it's allow only. You can't do a denial. So if you want to allow, say you're a platform team, you want to allow a developer or group of developers to manage some deployments in the cluster, but you don't want them to manage deployments or daemon sets in the KUB system namespace. That becomes really painful as a platform administrator, because you have to create a RBAC policy in every namespace for those developers. If you create a Kubernetes cluster role, you have to give it either every permission on every namespace or just specifically named namespaces. There's no conditions. That becomes really painful. So there's no conditions and there's no denials. Cedar is a access control language and runtime evaluation engine that's open source, built by AWS. It was launched several years ago at reInvent. There's also a managed service for this, Amazon Verified Permissions. But Cedar can be used for actually even your own applications. You can define what kind of actions can be permitted by who and on what resources. So over the last few months, we've built and then open sourced a new prototype for reimagined Kubernetes authorization using Cedar, and it's on GitHub. So you can see the link here. You can actually download it and try it out. We're going to show a demo here in a second. But I want to show just kind of quickly what this looks like. So if you've never seen Cedar code, that's okay. Cedar is very, very easy to read. Cedar policies have basically three parts, we'll call them. You have a effect. So in this policy, this is a contrived policy that doesn't do anything because there's it's not actually used, but just to show you kind of what can be done with Cedar. There's an effect, so a permit or forbid. This is a permit policy. Then you have the main section of the policy where you have principal, action, and resource. You define what principal can make an act can be this policy applies to. You can define what action or set of actions that this policy applies to. So I'm saying here, principal is a custom user, not a specific one, but just that's the type of principal. The action is in the list of get or list. So it can be either a get or a list action. And then the resource is some custom resource type that I've allowed. But it's now has something that you can't do in Kubernetes RBAC. It has a condition. We have this when clause. We're only going to allow this policy to take effect when a principal is in a specific group. And so we have a custom group type we've defined and an identifier for that group. So maybe it's a name. And then one other part to this condition is that the resource has some field on it, and that field must equal cool value. And then finally, there's a syntactic sugar called that's another condition on Cedar policies called an unless clause that negate when this policy applies. It makes it a bit simpler than having to write and or not equals to in your when clause. You can just add an unless clause as well. So this policy will all take effect with the when unless resource.myKind attribute equals secret. So if that attribute equals secret, this whole policy doesn't apply. So that's just a really quick walkthrough of Cedar. Now we're going to do a really quick demo of what this looks like. All right, so I want to show you a few policies that I've written here ahead of time. So, and then we're going to walk through and kind of see how this works. So the first policy I've written is a authorization policy. It allows a principal that's a Kubernetes user to do an action. And so that the actions that it can do are create, and these are just Kubernetes verbs: create, list, watch, update, patch, and delete. And then the resources it can act on are Kubernetes resources. So if you've ever written an RBAC policy, there's non-resource URLs like metrics, liveness checks, and then there's resources. So any secret, pod, config map, CRD, those are all resources. So we're going to say, okay, this acts on resources. But this only applies when the principal name is sample user. The resource being acted on is a namespaced resource. So this excludes resources that don't have a namespace, like node, validating admission configuration, a number of other Kubernetes types. The namespace name is default. The API group is empty, which is the core API group where pods, config maps, and everything live in Kubernetes. And the API resource is config map. So we're going to allow the sample user to basically do all these verbs on config map. So that's our authorization policy. This looks sort of similar to what you could actually do almost all of this in RBAC, right? It's a permit, so it's not a forbid, and all of these expressions could be modeled in RBAC. Now we're going to do something a little bit different. So we're going to add a second policy that's a forbid clause. We're going to forbid users that are in the group requires labels. So Kubernetes users are in groups. They are forbidden from listing and watching any Kubernetes resource unless the request has a label selector. So if you've ever listed Kubernetes resources like pods or any other resource, you can do with kubectl-L for a label selector, key equals value. You can specify keys and values. So in this example, we're going to forbid all requests unless there's a label selector where key owner equals the requester's name. This is something you can't do in RBAC. This is attribute-based access control. So we've now restricted some of those verbs that we saw above. The next policy is not just Kubernetes authorization, but Kubernetes admission. So Kubernetes admission is another part of Kubernetes where you can restrict mutations to resources. So creates, deletes, updates. So again, we're going to apply this to users in the requires label group. They are forbidden from creating, updating or deleting any resource, period, unless that resource has metadata. That metadata, so if you've ever configured a Kubernetes resource, it has metadata in the object meta and labels. And one of those labels is owner is principal name. So you can no longer, we're going to forbid users in requires labels from creating any or updating or deleting any resource unless they're the owner of it. And then finally, we're going to do a similar forbid on update, but we're going to prevent overwriting. So when you get an admission request for an update, you get two resources. You get the new state and the old state. We don't want to let someone overwrite a resource that they didn't already own. So we're going to forbid if the old object metadata didn't have owner is name, we're going to forbid that. Okay, so that's our policy. So I've already created this in a local Kubernetes and Docker kind cluster. And we're going to walk through what that actually looks like. Okay, so I have a KUB315 here that I've written that is a sample user, and I'm using the Kubernetes client call kubectl auth who am I, and this is just going to return back what user are you, what groups are you in. So I'm the sample user, I'm in the group sample group requires labels that we saw in our policy and a system authenticated. I want to as admin, so I'm the admin of the cluster, not as that other KUB315. I want to create a config map just for display purposes here. Okay, so I created a config map called other config. It is going to have just the key and value foo bar, right? Doesn't need any data. We're going to label that config map we just created with the owner some user. So not our sample user, just some other user. Now we're going to just get config maps that exist and show their labels. So there's three. There's kube-root-ca that's already there. That's created automatically by Kubernetes. It doesn't have any labels. We have this other config owned by some user. We have this test config owned by by the name default. Okay, so none of these are owned by our sample user. As our sample user, if we try to kubectl get CM or config map, we're going to get a forbidden. And we're not only going to get a forbid, we're going to see what policy denied that request. So you can see here that the policy label enforcement policy 1 on line 21, column 1, forbid this request. So I now know, okay, I'm forbidden, and I know which policy forbid me from doing this. If I want to try to label, so I want to update an existing, that other config, and add the stage equals test label, I'm going to get forbidden from that because I don't own it. If I want to create a config map as my sample user and I try to do that, again from literal where K1 equals V1, but I don't have any label on this config map I'm trying to create, again, I'm going to get denied. This is a admission denial. You can see admission webhook denied this. So far this is pretty effective. So how do we actually do something as this user? Okay, so here's a sample config map. I have it locally in a file called sample config. Notice that it has a label, and the label is owner equals sample user. It just has some dummy data of stage equals test. So what happens if we actually try to create this as the sample user? Okay, let's try it. It succeeds. This is great, right? This is what we actually want. And then as the sample user, if we want to list config maps, so get config maps with a label selector, remember we tried it before without a label selector, we do it with a label selector, it succeeds. But we can only see the one we own. We can't see any else. So that's our short demo here. The few things to note about Cedar is that Cedar is really at this point a prototype. We want to hear more from you. If you would like this integrated into EKS, we would love to hear about it. You can go ahead, download it, try it out. It's all open source. Yeah, again, we would love to hear what you like, what you don't like, what you'd like to see about this. But for now, this is an open source project that we're really excited about and want to get more information on from you. Finally, a few resources, as we mentioned throughout the talk. We have an EKS best practices guide. This is on the AWS documentation. There's a QR code here, so you can really read more about these best practices that we've mentioned here, as well as just Kubernetes specific ones that aren't specific to AWS or EKS, but just Kubernetes in general. We have the EKS workshop, which is a great guided tour of if you're new to Kubernetes, new to EKS, and you want to learn how to create an EKS cluster. It's a great guided tour of creating a cluster, configuring it, installing applications on it, like monitoring stacks, and other add-ons. It's really, really helpful. And then also we have EKS blueprints that we provide. These are sample configurations for Terraform and AWS CDK to help you get up and running and started very quickly with EKS. Finally, we also have a public roadmap. So if you go to GitHub on the AWS organization, the containers roadmap, there's a link here. You can see a list of feature requests by users or issues that we've opened to say, hey, this is something we're thinking about, we want user feedback on. You can upvote features that you want in EKS there. Or tell us about your use case. We want to hear about that. There's one for Cedar, integration into EKS. So if you like that, if you want that, plus one that. But you can also subscribe to updates. So you'll get notified when features are in development or when they actually ship. We use this actually, our product managers use this all the time to gauge, okay, what's the most popular issue? You can all go see it. You can sort by plus ones to see what's the most requested feature for EKS. And with that, thank you. Appreciate your time today. George and I will be available after the talk for Q&A outside. Thank you, and all. Have a great week at reInvent.
Thank you.